All right, everyone, let's get started now. I can start the live stream. So we are streaming this online, but hey, everyone, welcome. I see some new faces. I see some old. So thank you for coming. My name is Justin, and this is Toledo Codes. Today, we're going to be doing a little bit of vibe coding foundations. So the goal today is we're not going to put, sort of pen to paper yet. We're going to talk about the foundations of of vibe coding principles that you can use. Some caveats around, what does vibe coding mean? What are the caveats around vibe coding? What does that look like if you're not a developer or if you are a developer? And then, during this talk, the whole point is to make this very interactive. So I'm not going to do any live demos or anything like that today. This is a foundational talk that leads into next month's talk, which will be more hands-on. So we're going to do an actual workshop together. There's a little bit of homework that's optional if you so decide, but that's just going to lay the foundations, pun intended, for the next session. So if you don't know, Toledo Codes, we host these events every third Thursday here. There's always free pizza. So if you don't know, there's pizza out there. Please grab some. Please grab some. And at the end of the event, there may be leftover pizza, and I will ask some people to take that away as well. And we do these events every third Thursday here, right here in the same room at the Tech Loft. So thank you for coming out. And so, to start this off, I'm gonna just kind of jump in a little overview of how this thing's gonna work. So effectively tonight, all of these principles are portable. I'm not gonna be teaching you things tonight that apply to Claude or Codex or Cursor. These are foundational principles you can use in any of these tools, and it's tool agnostic on purpose. And for this, I'm not assuming coding experience, and this is going to be interactive, so please interrupt me, raise your hand. If there's a term you don't know, you can either look it up or you can raise your hand and ask, or there are some folks, can experienced developers raise your hand in the room? Can I get some folks? Okay, so you might see some hands around here that we have experienced software devs. If you have questions, feel free to ask them as well. So we'll go over where the terms come from. So where does even the term vibe coding, where does that even come from? What does it mean? We'll go around something called intent-driven development. We'll go over sort of a 5-stage ladder from making a prototype, or start from manual typing to effectively cloud-based agents. We'll define what an agent means here in a little bit. We'll go over something called the compound loop. So that is plan, work, review, compound, and what that means. And what it means for what we build. So, and all of that. So we'll jump right in. And again, I think this talk's 40 minutes is what I estimated, but I talk quickly, so we'll get it done in 20, 30 minutes, we'll see how it goes. So everything tonight is built from these terms. So we'll just go through all 6 terms. If you already know it, cool. If you don't, that's okay too. You might see the term repo. That is short for repository. You can think of it as a folder. It's effectively a folder, and it allows us to have different versions of that same folder all within that folder. There's probably a better definition for that, but that's what I'm going with for now. Pull request. These are proposed changes to a repo. That's all it is. It's just there is a diff, which shows you every line that changes in your pull request. And so good software teams we always have a repo. So we have a repository, we have a folder where we put our code in. We work on that together. And as you can imagine, if we're all working on the same folder together and person A makes a change and then person B makes a change, what's going to happen? Can anybody guess what's going to happen in that case? Exactly. Person B's changes are going to overwrite person A changes. How do we do that? We use version control. In particular, we're going to be talking about, I won't necessarily get into the weeds of version control, but the most popular of which is Git, and the most popular site for that is something called GitHub, which you might have heard of. Once we have a repository, we have a folder, we make changes to that via a pull request. And a pull request shows us a diff, a line-by-line demonstration of what's been added or removed. And then we have a couple of other terms here. So we have test. So a test is a program we run. It is a type of program that we run. It's a program we run that checks against our business logic. So what is it that our application actually wants to accomplish? Our tests validate that our application and in particular, a particular unit of code fulfills that requirement. The other two terms we'll see here tonight, and this is a term you've probably seen talked about quite a bit, an agent. What is an agent? An agent is an AI that actually does something. It doesn't just respond to you, right? It's not just a chatbot. It can open files, it can edit them, it can run commands, it can run things, and it can read the results of those things. And as you can imagine, we can chain agents together, or maybe you can't yet, but hopefully you will after tonight, that we can chain agents together to have them accomplish tasks. And then something extremely important that I will encourage all of you to think about and research is a sandbox. And that is a fenced off space where our code can run, where our agents can do work without sort of deleting our own file. So there is lots of examples on Reddit of somebody who said, hey, I let Claude run on my machine and it deleted my entire hard drive. Don't do that. Use a sandbox. Okay. We won't necessarily get into those details tonight of how you create a sandbox, but what I will say is that in our next workshop, I will go into that a little bit more. But I do encourage you to look this up. If you're running Claude Code, for example, it by default has a built-in sandbox. And I encourage you, if you don't know what this means yet, you should probably just use Claude Code for now and not use Claude Code yet. But we'll get to that. Any questions so far on these terms? Okay. So where does this term vibe coding come from? So it was coined last year, surprisingly, February 2nd by a man named Andrej Karpathy, or Karpathy. And an interesting, just to give some credentials to this gentleman, he was a co-founder of OpenAI and ran AI at Tesla. So he knows a little bit about what he's talking about. And he has a few repositories you can look at on GitHub. I mentioned those repo. You can look up on GitHub. And he can actually teach you, can actually build your own language model using his library that he has. So you can build a GP2 model, train it yourself. I think it's like $100 with some GPU to train your own model from scratch. And he demonstrates how an LLM works. That's not what today's about, but I highly encourage doing that or watching 3 Blue, 1 Brown's video on YouTube around how an LLM works. It's extremely complicated, but fascinating. But regardless, he says there's a new kind of coding I call vibe coding, where you fully give into the vibes, embrace exponentials, and forget that code even exists. And now, caveat this, the context with which he said this was not to say that we're going to deliver production-grade software and forget that code exists. The context he said this within is that a weekend project, this is great for, because you can give into the vibes. You can not care about the code and have something fun over a weekend. Again, not production software. So you should not be shipping software on vibes, in particular because there's security implications with that. So, as I mentioned, he was describing these weekend throwaway projects, accepting changes without reading them. And then when something breaks within there, and I'm sure some of you have done this, take the error message and you paste it right back in the LLM and you have it keep going. And again, his framing for this was it's good for weekend projects. And so within a few weeks, it's kind of escaped the confines of that context. And now vibe coding is this term that can mean just using an AI to program. And so we're going to separate that a bit tonight. We're going to divide that into 2 worlds. And those 2 worlds are vibe coding, where you don't read the code, and AI-assisted engineering, where you do read the code and you're accountable. And as professional software engineers, I know that I have a few software engineers who work at Actual Reality with me, and we tend to prefer the AI-assisted engineering route, is the route we prefer. So the dividing line, how do you know whether you should do this? Well, if you have a weekend project, vibe coding is great. If you're shipping production-grade software, so the dividing line here is, does this ship? Both are legitimate. If you're going to ship a weekend project, that's totally fine. But when there's security and other aspects in mind, you want to shift towards the AI-assisted engineering, which may mean hiring a software dev to review some aspects of your code base for security, etc. We're going to discuss a little bit more on the right side a bit more. I'm going to teach you principles that can apply to both. if you apply these principles that I'm going to teach tonight, you're going to start getting more into AI-assisted engineering, but you can still use it when you're vibe coding. And what will be the result of which will be higher quality code output. And I encourage you to measure this, right? Be scientific about it. When you go home after tonight, take some of the principles. I'll have the slides up on the website. Take some of the principles that you learned tonight and compare the difference of the output.
So is there a litmus test to kind of where does vibe coding and AI engineering begin?
So the litmus test is if you actually read the code. If you're reading the code, you're on this side. And I mentioned that we're going to lean more towards this side, but that's because I'm trying to encourage people to lean more towards this side as we think about software development, especially because I know a lot of folks, and I know folks in here as well, have side projects that they might have and that they're pushing to production. And I'm going to encourage you to either understand the code yourself or find someone who does, for good reason. We're going to talk about something called intent-driven development. And so what does that mean? It means we start with defining the what and the why. So what are we building? Why are we building it? It's kind of a good principle to start with. And typically in software projects, we do a little bit of user research first. We understand users' needs. We might go out and do user interviews. I might go out and talk to 100 people randomly on LinkedIn and discuss and distill that down into actual user needs. Because I can tell you as an engineer, I've had a lot of ideas and I've built a lot of products, and then I get it in someone's hand and they use it completely different than the way I had anticipated they would use it. So that's a step I'm not defining here, and it's a little out of scope tonight, but it's something I like to mention when we talk about how we build software. So first, we define the what and the why. The second step, what are the limits? So what are the things that we don't necessarily, what are out of scope for what we're trying to accomplish? And then defining what done means. So if I'm going to ship a particular version of this software, what does done mean for that? And so, if, for example, if I have a calendar application, my done should probably mean I should be able to send calendar invites to people, maybe attach a description and a name, right? Maybe actually send those emails out to folks, right? So you're getting into the nuance of it. And you'll notice here, we are thinking about this with our human brain. You can iterate on this with AI, but I highly encourage you to think about it yourself and reason your way through it. The next step in this is to actually generate. So we're going to have the model generate code and then verify. So we'll test, review with real users. And again, these principles still apply even if you're vibe coding. So even if you're not reading the code, you should have you should be having your system, your harness. So the harness is a term I probably should have added here, but that's Claude Code, Codex, whether you're using the application or the CLI. You're still going to want to write unit tests, review the application itself. So if you're vibe coding it, still pull it up, have your unit tests generated still. And ideally you read through some of that, in which maybe there's some jargon there. But understanding what it's actually testing is important, because that's actually where your business logic. That's testing what the code actually is doing. And it's important that you do validate that. But also just clicking around in the app, right? So if you have an application that you're generating, clicking around and testing that particular piece of functionality, documenting any failings, anything that's failed, and then kind of going back again. So we continue this cycle. Now, obviously, it gets to a point where maybe we're just kind of doing steps 4 and 3, but we'll get to another model that will describe this in a little bit more detail. But some of this, you'll see kind of in the bottom here, some of this is to say that we might have gotten to a point where we need to update our specification or our intent as we're going along. And there's a 5-stage ladder that I think about with this. So, for a long time, we've been in sort of steps 1 and 2 world. A little bit of 3 if you count Stack Overflow on that, for some people who know what that is. There was a point in time when you would have folks who would just copy and paste code from Stack Overflow, which is a website where you could ask questions about your coding problems, which obviously they're probably having a bit of issues.
And people responded.
Analog AI. Yeah, and humans actually responded, and they got points for it and everything. It was a whole thing. So we can see this journey from manually coding. So you're holding the keyboard here. You know, there's this funny meme which I wish I would have included here, which I won't even describe it. I'll just share it in the Toledo Code Slack. We're gonna tab completion in your code. So some of us know what that means. That means we have a particular program we run on our computer called our IDE, our Integrated Development Environment. And we were just, I got to a certain point probably 5-6 years ago, a little bit before ChatGPT 2 came out, or ChatGPT 3, I should say, where it would auto-complete your code using language not using language models, but using machine learning models. And then we got into chat, which we talked about, which, you know, that's sort of getting into ChatGPT. Now we're starting to get into 4 and 5, where we have an agent running on your machine that's generating, it's reading files, right? And I don't know if any of you have seen what that looks like, and maybe we can do a little demonstration of some of that. I don't know if any of you have seen it, but you know, it opens up files. It can run and execute programs. It can open up the browser and move the mouse around and click and grab snapshots from the website. It's incredible. And so now we're getting into this point now where Codex, so ChatGPT's coding harness and Claude Code can now run in the cloud. So you can give it a task, and I do this all the time, where I can go into Claude, give it a task to do, leave my house and pull up the Claude app on my phone and follow its progress along, and even prompt it, and it will run commands on my computer. So it can execute programs that are running on my computer. And you know, you can, if you're creative minded, you can think, if it can run programs on my computer, there's a lot that it can do. I think earlier I was working on something to vibe edit, you know, videos using DaVinci Resolve, and just having DaVinci pop up programmatically and have this application do, you know, having Claude actually doing things within DaVinci is sort of wild, which DaVinci is a video editing application. And then I mentioned we have the cloud-based agents. And so this gets into a principle. I did a talk recently at Mommy Schools where I sat in front of the group of teachers as they were getting ready to start their year. And you know, one of the questions was posed about what are the things we should be thinking about in the future. And you know, one of the things I think about a lot is that, you know, every developer who steps into, you know, to their first software job, they have an incredible feat ahead of them, because as we now have these agents that can code in the cloud and do all of these really interesting things, you're stepping away from being an individual contributor and you're now becoming an engineering leader. So you're having to think about things from end to end that you've never had to do before. So you're no longer the author, you're directing, because it opens the project itself. It's writing the code itself. It can troubleshoot and review code for you itself. It can audit, you know, it can go through and do a whole UI audit and look at your user interface and tell you, run accessibility tests, automatically fix contrast issues, and you know, the list goes on. And when we start thinking about the sort of stage 5 of this, I can then give it, once I've reasoned through, remember in intent-driven development, we're defining the what and the why, we're writing a specification to define what done is. Once we have that, and then the system can then, you can imagine an agent can then break that down into tasks. And then it can execute those tasks in parallel, meaning it can do all of them at once. And you can imagine then you could review its work one at a time. And so you can describe the work you want to do, and it can run them concurrently, which effectively means in parallel. And then you're going to get each change can then come back as a pull request. So you can either human review it, you know, or you can have, there are lots of tools out there now that will review it on your behalf. So you can have even another language model then review your pull request and tell you if this is good or bad. And so obviously, if you're not looking at the code itself, you're on the vibe coding on that left side of the chart earlier. So you're sort of managing this concurrent work, And then the bottleneck is no longer software development itself. The bottleneck is no longer sitting down and writing the code. It's actually reviewing it. And I think we've seen some of that at Actual, right? Where, right now we kind of get bogged down with pull requests, which again are the changes that are coming in. And I'm looking back there because there's some actual reality devs back there. Okay, this is all fantastic, and this beautiful wonderland sounds amazing, right? We're in this wonderful future where AI is generating all this code, and it's rainbows and sunshine, and everything works, right? No. More often than not, it breaks. And where it breaks, almost every time, is because of one of these things, right? So number one, context or confident wrongness. So it will confidently tell you that it's correct, and it may not be. And unless you know or understand what it is that it's doing, you won't know. You'd have professional-looking, beautiful code that's wrong. It's a very possibility, and it's frequent. As Sean said, it's frequent. We get into review debt. So maybe you have 100, maybe you have 20 parallel tasks that have gone out. Now you have 20 pull requests to review. You could go through and just merge all of them, but you're likely going to have breaking software. So you have to review it's generating code faster than you can actually review it. And we'll understand what compounds in the wrong direction is soon, I hope. And here's another one that I think a lot of people fall into the trap of, and that's context rot. What that means is that let's say that you're working with your AI and you have a session and you're chatting with it, right? And you've been chatting with this session for a while. You've done your intent, you've done your specification, you have some tasks that it's generated. And if there are great frameworks to help you with this, by the way, too. There's some superpowers and a couple other skills that are out there that help with this. But you're in this one session chatting with it. Now, after about, the context window for these models might say it's 1 million. It's very common. You might say it says 1 million token context window. You can think of a context window almost like memory in a computer. So if I have 1,000 memory, we're just going to say a unit is just called memory. If I have 1,000 of that memory, as that context window fills up, so as the memory, a unit of memory fills to that 1,000, once we hit the 1,000, it no longer can recall things from the beginning of that conversation. So what do we do? So there are lots of ways to do this. One of popular way is to generate a handoff. So you can tell it, hey, let's hand off and we're going to go into a new session together. And then it'll write off a markdown document, which is a particular file format. It's pretty straightforward what a markdown is, what markdown is. Most of these tools now understand it. That's sort of the new language we're writing code in, I suppose, these days is markdown. So this one is very common, and this is something that I encourage you to set up either some kind of meter. You can do it in Claude Code. So I think, yeah. So this is actually the session that I generated those slides in, that I also human reviewed. And at the very, very bottom here, oh, you can't see that. That is not the thing. Probably because I'm sharing. Yeah, here we go. I will increase the size. So in this very, very, very bottom corner here, you might see this yellow meter here that says 52%. That's my context window. So I've used up about half that context window, which means I've used about 500,000 tokens in this session. As you get closer to 70%, it stops recalling things from the beginning of your conversation, which can be bad. So, in this case, I would generate a handoff document. I would, clear my context, and then I would basically copy and paste that URL to or the address to where that handoff document is on your computer, and then I would start a new session again. So that's context rot. The next one is verification gap. So if you don't have tests, now, thankfully, the models are sort of forcing this paradigm where it's writing those tests. Again, it's another program that you write alongside your code. So yes, you're writing code for your code. But we do this again so that we can validate that business logic. And without having those tests, again, it can confidently say it's working, and it's not. And then another is blast radius. So this is where security becomes extremely important, especially as you think about building, if you're vibe coding an application that maybe has users, right? So let's say you have a mechanism, which is very common, where I want users to be able to sign up and create an account. Well, as you start getting along in there, you're going to have to store passwords. You're going to have keys that either secret keys as you set up accounts. Let's say you want them to be able to log in with Google. Well, as you're setting up your Google open authentication or OAuth, it's going to have some keys that are related to that, and those are cryptographic keys that are used to make sure that your sessions are private. So as you're chatting with your tool here, as you're chatting with Codex or Claude or whatever, you might paste one of those into a session, right? Well, now you've just leaked a security item and that's being sent over the internet to Claude. So there's a bit of a security loss with that. And let's say that as well, you commit all of this to Git. Well, you might not realize that Claude's actually storing your entire conversation right inside of your repository, right inside that folder. And now you've just pushed code up. You pushed all this stuff up to GitHub, and it has in that session history that password or that key in Git now, forever, unless you go through and rewrite Git history, which is a whole nother. We could have a whole talk about that. So there are mechanisms in place to do this. So Claude does have mechanisms to hide, and I think they use the exclamation point or something like that to hide your hide sort of secrets. But it's almost better to just manually edit them. So it might say you need to add this thing to a file. Just go add it to the file. And we have Twitch spam. Any questions on this so far? Oh,
Actually,
James, real quick, sorry.
I was going to say, what do you think about compaction?
That's a good call out, actually. I think you can compact your session. I've had hit or miss luck with compaction because you're sort of letting the model decide what is relevant and what isn't. And it can be good at that. I often find it better for me to just generate a handoff, have it write the important details, read the handoff, and then clear my context and start over again. But you can use something called, I think it lets you do a /compact. Yeah. Where it will free up your context by summarizing. I personally tend to not do that, but that's also a personal preference. But thank you for that.
My question was about, you mentioned it uploading your conversation history to GitHub.
Mm-hmm.
Is that automatic? Is that something that can be controlled?
So every repo that you create will have a .claude directory. This one doesn't. But it'll have this .claude directory that can store it. It's not always set up by default, and I think that they're discouraging that now to put that more on the user side, but just something to be cautious of.
Does Codex also do that?
Codex also does that, yes. But it's something you can look at the folder itself, and there are these dot directories that are typically present, and you can see them there.
You alluded to in your step, you say you're hit and miss with compact, right?
Yep.
So you're preferring clear because you create that handoff, then you read that handoff.
Yeah.
And you, as a human, review before kind of letting go and then starting over again.
Yeah, and if I'm being honest, there are times where I don't, but yeah.
Okay. So I guess it depends on how, again, how particular one needs to be with the app when we're vibe coding something versus something that's just a lighter, more rapid prototype versus a true production, what blast radius is. I do find, not as much with code stuff, but with others, is the tendency of things to change over time. and the need to check is almost as laborious as the initial creation. So I just want to highlight that point. We said, hey, I find a need to not just trust, but validate and make sure things are good before going to that next step. That's the whole thing, is the balance of how much you're trusting the tools versus how much you're auditing the tool.
Yeah. And I mean, obviously it's use your best judgment. Some of it is there's mission critical things that you really should review it a bit more. And some things, you know, whether if it's like a UI aspect where maybe you're making a web application and there's some things you might not care, you'll care less about on the front end of it. And I'm curious, James, with your question to follow up, are you using Compact in your workflows?
I do quite a bit. Like I really watch the context window. I will self-impact a lot early on. So it's worked pretty good for me, but I'm also using some really expensive models.
Fair, yeah. We haven't even got into model cost yet, but Casey.
You hit on unit tests a couple of times.
Mm-hmm.
Do you see, and this is more of an opinion question maybe, but do you see test-driven development as kind of a model that carries forward from the pre-AI era to the AI era?
Absolutely, yes. You know, I'm still a big fan of test-driven development, and that is where we will generate tests prior to even generating code or as a part of generating code, such that we can validate that business logic that I talked about earlier. And that's really codifying that intent. So back a few slides ago, we have this ladder from manual, you know, sort of manual coding all the way on up to agents and parallel cloud. So climbing that ladder up to sort of getting into the parallel agents can still make those mistakes, and as I mentioned, but at a higher volume. And so what fixes that is a loop, where the output of a task that you have improves the output of the next one. And this is something that we'll get into, and this is called the compound engineering loop. Now, there's some plugins that help with this. It could be as simple, like I have seen this as simple as I have some text in a document that I have in my repository. We call that our agents.md. You might have seen that, or a Claude.md. But we'll effectively have an instruction in there that effectively says, hey, every time you make a mistake, this is the durable rules, hey, it did something I didn't like in this session. Let's dig and understand what went wrong, why did it go wrong, and how do we make sure it doesn't go wrong again, and then document that. I'm adding that one step here, because again, I showed you the intent-driven development part earlier, where we generate a plan, we do the work, we review the work, and then we review what went right and what went wrong, and codify and generate durable rules that can then improve all of our future sessions. And this can be as simple as there is a compound engineering plugin that you can use. I believe made by Kieran Clausen. He made a tool called Cora. And you can use that plugin, or it can be just a simple instruction. And I found the latter is works perfectly well. So again, just to review this, so we talked about intent-driven development earlier. So we have our intent, we have our specification, we plan it, we do the work, we'll review it, and then we make sure that anything that goes wrong is codified again into our repository, such that it doesn't make those mistakes again. And so this gets into understanding what you're building before you get into building it. And that might sound straightforward, or might sound like common sense, but you'd be surprised, right? I know I've dove into projects without really fully understanding what it is that I'm going to build. So you have to state the goal. Again, some of this is review. What are the constraints and what done looks like? And you can do that in the chat window with the agent, but it's better to put that in some kind of file so the agent can review that every time you talk with it. And so the third bullet here, I think, is a critical one. You know, the cheapest place, because again, every time you chat with your agent in Claude or in Codex or ChatGPT, et cetera, it's costing you a little bit of money. It might use some of your usage. Now, we all probably here does everyone who has a Claude or Codex subscription here? ChatGPT subscription? Okay, so some, not everyone. Okay, so the cheapest place on earth that we can catch a wrong approach is before we even write the code. So I would argue that for anything, it says for anything touching more than a couple of files, plan first. I would argue always plan first. And the test is, can a competent stranger execute this plan without asking you a single question? I guess that's a good litmus test to say, have I codified the goal, the constraints, and what done looks like? And by codified, what I mean is to say that we sort of write it to a file on disk, is the easier way to say that. And I'm going slower than I thought, actually. When we do the work, we want to do small verifiable increments of work, one logical change at a time. Why? Because then we can review it. We can, as a human, you can review what the application's doing. If you're a programmer, you can review the pull request, and it's a smaller unit of change. It's one thing, that this is pre-AI, even when we were making, and I know all the software developers here can attest, we have to make a small change so we can review it, and we only have so much capacity in our brain to understand. Once you've written a giant code base, you come back to it 3 months later, and you're going to go, "Oh, I wrote this." I don't know if has any software developer had that experience here? Raise your hand. Yeah, I know I definitely have. And so agents are going to have the same problem, right? As your code base grows, they're not going to be able to review the entire code base because that context window we talked about earlier. If you pull the whole code base into the context window, it might fill it up and some. So what do? We make small, verifiable, incremental changes, one logical change at a time. You write the test first when behavior matters. So the tests are going to state the business logic. And then the agent that can then fill in the code as a result of that. And I think a good logical, rules of three are great. So if 3 fix attempts, if you kind of have a circle again where you're copying and pasting the error back in there, and you've gone 3 cycles or 3 loops of this, you should stop. There's probably something wrong with your plan. Take a step back. And firing off those random fixes and hoping is the fastest way to produce a lot of bugs. And so again, we want to do small logical changes. We make pull requests for those changes, either have an agent or a human review those changes, merge them in, and merging just means we accept those changes into our folder, and now the folder has that change. And that's it. And we repeat this for all of the items that we have in our plan. And if you're looking at the code itself, now this is vibe coding foundations, but I'm trying to instill the fact that whilst vibe coding is a paradigm that can lead you to producing a great weekend project, again, if you're going to produce something that you want users to actually use, you should be following some of these principles. And it says review the diff, not the vibe. We defined what the diff was earlier. That is the changes that are being made. And I think I can pull up probably something in here. Oh boy. Oh, let's see this. Here we go. Just to show. Don't worry about what you're looking at here. Other than the fact that don't worry about the content of what you're looking at here, to reword that. So you can see we've got in red here, it deleted something, and in green it added something. That's really all the diff is. It's pretty straightforward to read and follow and understand. And then you see we've got 2 AI reviewers that are commenting on these sections of code.
The comments on Markdown. Right?
The comments are on Markdown, yes. On .md files, yes. We're going to call that code.
Yeah.
And you can automate some of these things. So you can automate some, you can have your agent kick off and automate some things like making sure that the code is valid. It's generally a good idea to do before you're actually saving those changes and making a pull request. It's great to sort of review that before you do that. And you can do that by creating some automated tests to look for type, run your unit tests, do something we call linting, which is almost like spell checking for code, but just kind of make sure that it passes sort of litmus test of, is this code doing things correctly the way we would expect them to be. And an agent or a friendly human around here can help you think about and set up what those lint files might look like depending on your project. And the things you want to spend your attention on are, especially if you're vibe coding, is, does it solve the actual problem I'm trying to solve? So if I have a particular functional unit let's say that I'm building the calendar application again, and I want to build sort of the invitation flow. So I want to be able to add attendees to my calendar event. And I'm building that functionality right now into the application. Well, does it accomplish that, right? Like, I'm running it locally. Am I able to invite somebody? Do I see the invite come into my inbox? Did it do something it shouldn't? A lot of times you can set an AI agent off to go do a particular task, and it might try to fix something else. And that might be fine, but it's better to isolate that, right? And say, let's leave that alone for now. We'll file, maybe you can create a markdown file with some issues, or you can use a tool like Trello, sort of track these things. I highly encourage you, if you haven't used Trello, it's pretty simple to set up, and you can have your agent sort of write tasks in there, write comments, and it's a great way to follow it, follow it so that you don't have to necessarily look at all the specifics of what it's doing, but you can see it's, okay, here it's working on this particular component, this task. So if I'm building the calendar application, for example, and it's working on that, and it just committed that piece of code, I could see that there's a Trello card that says, ability to invite attendees, right? Or something like that. Jason.
Talk about Trello. How often do you use Trello versus using like issues in GitHub?
Honestly, they're all interchangeable. I mean, I've used GitHub issues when we did a game jam. I used GitHub issues as my sort of place of truth. To be honest, I'm not even really using Trello anymore. It's just a great example. But GitHub issues is actually great, because if your agent already has access to GitHub, it's likely going to have access to GitHub issues. So that's a decent place to start. But I'm using these days between linear, GitHub, open source tool called Plane, which is basically a linear clone. So it's really just sort of choose your poison.
Depends what your team chooses to.
Right. Depends on if your team is prefers GitHub issues. If you're solo and you're not a developer, Trello is fantastic. It's really simple to follow. So I recommend it. Here we go. We're getting into the last phase here, so compounding. So I mentioned earlier that we're writing down the rule that prevents it from making that mistake. So let's say, again, I go back to the calendar example, and we're building, again, the calendar app. We're working on the feature that can create, to add attendees to it. And it continuously makes this bug where it's not sending the email to the other attendee, right? And I dig through and I figure out that this particular bug was a result of some instruction I gave it earlier. I was going to use the Gmail API, Google's API, or something like that. And it wasn't doing that. So now we can make sure we can go in and correct it and say, okay, you always use this particular API. So you correct the agent, and you're giving it instructions that it can then use on every subsequent run. That's what compounding is. That's all it is. It's very straightforward. And I would argue this is the one that, like, a lot of people tend to skip this, but this is the one that's going to make it a lot easier as you work on the project, because the goal of compound engineering is to make it so that as you work on your project, you're making it easier for the next person and for yourself. And so you're thinking about future you. And so, like I said, you're not going to put those in the chat. You're going to put those in files. So we're going to create an agents.md or a claude.md. A convention I highly recommend is to just create an agents.md, because all the tools use that. Claude uses claude.md, obviously. And then you can actually just reference the name of it in there. You can just say, hey, go off and include the contents of this file So you can keep your agents.md as sort of your master file, and then you can have your Claude MD be sort of just references the agents.md. And I wish I would have had an example of that, but I don't. But it's fairly straightforward, and I'm happy to show anyone who would like to see it. Skills and prompts as well. So these are things that if you find yourself repeating a particular action, turn that into a skill. You can actually commit that skill right into your repo. So every time you're using this project, you will have that skill available to you. And then if you find that you want to be able to use that skill for other projects, you can then pull it out into your personal Claude, because you might not know this, but each repo or each project you're working on has its own Claude files, and your user on your machine has its own files. So it has its own skills and prompts that you can use. And then you can even codify your review cycle with agents as well. So you can you can define what they call sub-agents, which go spin off in the background and do a particular task and sort of invisible to you. But you can define and codify some of these things that you're doing. And I mentioned tests and lints and types already. I'm going to kind of move quickly here because we're already over time. And so the loop here, we talked about this already. Read a plan and change it before a line is written. Let it run. So the agent runs and opens files, runs the tests, reads what comes back. You review that. So go through and click through your application. A lot of times what I like to do is define what we call a smoke test in the industry. So maybe my calendar application, again, example, I might define all of the behaviors that I'm expecting from my application as I'm developing it, and then effectively build myself a test that I can go back to in a checklist and go, okay, I can go and click this. Can I sign in? Yes. Great. I didn't break sign in. Can I create an event? Great. I'm able to create an event. Can I invite attendees? So on and so forth. So it's just a nuanced set of instructions that you as the human use when you're testing your application itself. And then again, every time it does something wrong, we write that down and we update our agents.md or however. There's other means of doing this, but this is just a good example of doing it, of a method for compounding. I'm going to skip that. And so I read this article recently. This guy, Jeremy Morrell, wrote this article about how we write extensible software in the age of LLMs. I'm going to skip some of this for now because, again, I'm already over time where I wanted to be. But I'm just going to quickly talk about this because I think it's really interesting. And has anybody ever used like if this, then that? I think it's if this, then that, or have you guys used that? You've used IFTT? Yeah. Effectively, what it would, or like even, what's another one of those examples? Zapier, yeah, Zapier, something like that, right? So there's, or even now we have N8N, I think. And effectively, what it's done, if you use any of these tools, it's defining functionality. And so I think this probably gets in the weeds too much, but it's defining functionality to say, I can send a tweet, I can read a tweet, etc. And as you start thinking about how you're building your applications, you can define some of these behaviors or these actions that your application can take. And then that effectively gives you this extensible system that you can build on top of. And I probably should have just skipped this because I'm realizing now this is a deeper topic than we have time for. So to quickly summarize things, and just a little homework for you first. Pick something that you would like to work on. This is if you're going to join us in the next session. The next session will be more of a workshop. Today is just sort of the fundamentals and foundations of these ideas. Next month, so in September, we're going to do this again, but we're going to do a little bit more hands-on. And by a little bit, I mean a lot more hands-on. But during that month, so you have 4 weeks from now, pick something you'd like to work on. Create your agents.md file. And again, you can, if you're not in our Toledo Code Slack, I'll show you guys how to join that. You can join the Slack and ask questions if you need help. There's lots of developers who will be able to help you and even help you do this step, right? And I'd be willing to do that. I know there's lots of folks here as well that would help. Then follow these steps that I've outlined here. And I'll share the slides in the Slack first because I always say I'll have the slides up on the website and then it takes me 2 weeks. So I'll just upload the slide to the Slack. That way you can see it. And then actually follow these steps. And I'd like to see what you guys come up with the next time. So even validate against a previous workflow. So if you've already tried to sort of vibe code an application, use these principles and see if they improve your workflow. And if they don't, I'd love to hear that. I'd love to hear the feedback. Okay, quickly before we end this, I'm going to talk about what we don't vibe code. Right? We mentioned that what are the things that we vibe coding is we don't look at code. Well, if we're doing login and permissions, we don't vibe code that. If we're doing payments, we don't vibe code that. If you're holding PII or personally identifying information, we don't vibe code that. And if your application is worldwide, and let's say you deploy something and you have personal identifiable information, I really want to let you know you are financially responsible, because if you leak that personal information, I think it's, does anyone know the EU's rules around, I think it's like $30,000 to $50,000 per violation. So, if you have 10,000 users, looking at a cool $3 million, $5 million fine. Plus possible jail time, yeah. So, don't do it. Database changes or anything that deletes. Anything you cannot verify, don't vibe code it. You can either ask for help. There are lots of people online. If you ask for help, they'll help you, right? And so or in some cases, if you're building production grade software, and you'll have to excuse my language here, this is one of my favorite talks. You might find a developer and they're going to say, well, fuck you, pay me, right? So there's some of that as well. Okay, so again, Thursday, September 17th, we'll get quite a bit more into the weeds. We're actually going to build and design something together in person. I wanted to sort of lay down some fundamentals today for some ways we can think about vibe coding, what vibe coding is. I hope it's been at least somewhat educational to you. And the next time you come, bring a project you actually want to work on. So if you have something you would like to work on, bring that agents.md that you wrote this over the next few weeks. And then by the time you leave the next session, you're going to leave with something that's actually working, and you'll get a full vision of what the loop looks like. And there's lots of folks even in this room that can help you understand that from end to end. So thank you. I appreciate everyone coming. We do have lots of events on our Luma calendar. That I believe this is the RSVP for the second session. So if you would like to join us for the next session, I highly recommend RSVPing. And also thank you to Lot 419 for hosting us. They're so gracious that they host us here every third Thursday. And they let us use the space for free, which is fantastic. And also, so that's it. Thank you so much. Appreciate everyone for coming. And there's still pizza out in the hallway. Please take it. Did you get everyone already?
And if you didn't sign in, please, there's a paper right here on the end of this table. Please sign in.
Thank you, Sean. All right. Thank you all.